A dramatic shift occurred in our understanding of cosmic visitors. When 3I Atlas reached its closest point to our Sun on October 29, 2025, this mysterious object executed maneuvers that nobody anticipated. The behavior has triggered an urgent scramble among researchers desperately seeking explanations. The discoveries are compelling scientists to pose inquiries they never imagined would become necessary. We're not discussing just another frozen wanderer. This represents an entity that journeyed billions of years through the void separating stellar systems, an object whose behavioral patterns fundamentally contradict every expectation. The observational data grows increasingly perplexing. Allow me to illuminate what's unfolding at this moment, because recent events have fundamentally transformed our comprehension of this cosmic visitor. As 3I Atlas drew near Perihelion, something extraordinary manifested. The object's luminosity didn't merely increase gradually. Instead, brightness values exploded upward at unprecedented rates. The luminosity surge occurred at double the velocity compared to its previous brightening rate, literally twice as rapid. Astronomers Qichang Zhang at Lowell Observatory alongside Carl Badams from the Naval Research Laboratory captured real-time documentation as it unfolded, and neither possessed any theoretical framework to explain the observations. This entity has been traversing interstellar space for billions of years, navigating through environmental conditions that strain our imagination. Now, approaching our star, it suddenly manifests dramatically heightened activity levels, exceeding any model's predictions. Why is this happening? The spectroscopic analysis revealed something fascinating. The electromagnetic radiation shifted toward shorter wavelengths, becoming measurably bluer than our sun's spectrum. This blue shift indicates carbon-based molecular species, specifically C2 and NH2 compounds. These represent unmistakable fingerprints of active ice sublimation. However, here's what renders this profoundly unsettling. Radio observations detected that in just 2 weeks before perihelion, 3I Atlas was losing approximately 5.7 times 10 to the 28th power water molecules per second. That represents 40 times greater mass loss than 1 month earlier. 40 times more water vapor pouring into space at kilometers per second, like a fire hose at maximum pressure. Your initial response might categorize this as normal cometary behavior. Comets absorb solar radiation, ices undergo phase transitions, luminosity increases. Standard physics, except 3I Atlas fundamentally refuses to follow standard physics. The rate of change contradicts established models. The timing violates expectations, and the data doesn't match our accumulated knowledge about comets from our own solar system. Space-based telescope platforms including SOHO, Stereo A, and GOES 19, all equipped with coronagraph instruments, successfully captured detailed imagery throughout this critical period. The data revealed characteristics that veteran researchers found deeply unusual and difficult to reconcile with existing frameworks. The comet manifested as a faint yet elongated luminous region. However, here's what's generating controversy. The object displayed absolutely no visible dust tail structure whatsoever. None at all. Not even the faintest trace of the characteristic dust trail that comets universally produce. What does this absence signify? Several research teams suggest that initially, carbon dioxide gas was escaping at approximately 3 astronomical units from our sun. This sublimating CO2 would have been cooling the surface, functioning as a protective thermal barrier, preventing underlying water ice from sublimating. However, something fundamental changed. That protective layer became depleted, and when exhausted completely, the water ice underneath suddenly found itself exposed to direct solar radiation at intensities orders of magnitude higher. The result manifested as an explosive increase in brightness and activity. But there exists another theoretical possibility. The fundamental composition of 3I Atlas's nuclear structure might differ so dramatically from anything documented that conventional comparison becomes meaningless. This object didn't form within our solar system. It coalesced around an entirely different star in a completely different environment, subjected to different chemical patterns, different temperature gradients, different radiation environments. What if its internal architecture resembles nothing like the comets we've studied? What if exotic materials exist within that nucleus that our frameworks don't accommodate because we've never encountered them? The James Webb Space Telescope has been systematically observing 3I Atlas, and Webb's analysis adds another perplexing layer. Webb's near-infrared spectrograph revealed that this comet has undergone fundamental transformation throughout billions of years of continuous cosmic ray bombardment during its interstellar journey. We're discussing galactic cosmic rays, extraordinarily high-energy particles that permeate the interstellar medium, striking the comet's surfaces continuously across eons. According to research led by Romain Maggiolo from the Royal Belgian Institute, these relentless impacts have fundamentally altered both physical structure and chemical composition at molecular levels. Sophisticated computer simulations suggest that cosmic rays carrying energies measured in GeV have penetrated approximately 50 to 65 feet deep into the surface layers, creating what scientists characterize as an extensively irradiated crust layer. This transformed shell no longer resembles the pristine, primordial material from billions of years ago. It's been thoroughly cooked by radiation exposure, transforming into something else entirely. Here's the paradigm-shifting realization, forcing researchers to reconsider fundamental assumptions. Scientists have been hoping that interstellar objects would function as pristine samples, providing an observational window into other stellar formation environments. However, if Maggiolo's radiation processing hypothesis proves correct, then what our instruments observe isn't any pristine sample. Instead, we're examining a heavily modified radiation-processed shell fundamentally transformed by its journey through harsh interstellar radiation. Maggiolo stated clearly that 3I Atlas has become primarily a product of its interstellar journey rather than a faithful representative of its original formation location. This raises an obvious question. What lies concealed underneath that irradiated outer crust? What material exists within the core that might still preserve pristine composition, shielded by protective outer layers? Here's something most people don't realize. Professor Avi Loeb, former chair of Harvard's astronomy department, and a respected voice in the search for extraterrestrial intelligence, has formally requested that NASA release all accumulated scientific data regarding 3I Atlas to the broader research community and interested public. Why would a scientist of his stature make such an unusual public request? What does he suspect might be contained within unreleased data? The behavioral patterns following perihelion have become the primary focus of intense scrutiny. Scientists freely admit they genuinely don't know what will happen next. Will the dramatic brightness continue increasing? Will it suddenly fade? Jang and Batams noted that the post-perihelion evolution could prove just as unusual, possibly even more anomalous, than the dramatic outburst that preceded closest solar approach. That fundamental uncertainty represents exactly what makes this moment so critical. We're witnessing in real time as an object from beyond our solar system executes behaviors we cannot fully explain using existing theoretical frameworks. At perihelion, 3I Atlas achieved a visual magnitude of approximately 9. That places it bright enough to become visible through modest amateur telescopes if observers knew exactly where to look. However, the object occupied a position so close to our sun's glare that observing from Earth's surface became essentially impossible during that crucial moment. We necessarily relied entirely on space-based coronagraphs. The imagery revealed an object bearing virtually no resemblance to typical cometary structures. The high-resolution images revealed this elongated glowing form, lacking the expected dust tail entirely. Instead, observations indicate primarily gaseous emission without solid particulate component. The hydroxyl glow representing water vapor was detected by NASA's Swift telescope. However, the conspicuous lack of visible dust remains genuinely anomalous. Comets universally produce substantial dust quantities. It's what makes their spectacular tails so magnificent and scientifically informative. So where has all the dust from 3I Atlas gone? One theoretical possibility suggests the composition might be fundamentally ice-rich, with extraordinarily little solid material available to produce dust when exposed to solar heating. But that doesn't fully explain the explosive brightening. Another possibility exists. Perhaps the object's internal structural architecture differs so fundamentally from anything we've classified that conventional categorization becomes meaningless. Webb conducted extensive observations back in August before perihelion occurred. The accumulated data confirmed something earlier observations had merely hinted at. This comet exhibits unusually rich concentrations of carbon dioxide, abundances measuring significantly higher than typical solar system comets. However, more importantly, Webb's detailed spectroscopic analysis revealed that the outermost layers have been fundamentally transformed at the molecular level by prolonged cosmic radiation exposure. Here's what that transformation means. Within our solar system's boundaries, we exist inside a protective bubble created by the solar wind. This heliospheric boundary effectively shields everything inside from the majority of galactic cosmic rays. However, in true interstellar space, that protective shielding completely disappears. Objects drifting through space between stellar systems find themselves exposed to the absolute full intensity of cosmic ray bombardment continuously for millions or billions of years. Sophisticated computer models successfully simulated the cumulative effects when ice and rocky material experiences sustained cosmic ray exposure. The simulation results demonstrated that after approximately 1 billion years of continuous radiation exposure, the transformation process reaches completion. The outer layers literally become something chemically and structurally different. Carbon monoxide molecules undergo conversion into carbon dioxide. The crystalline structure of water ice fundamentally changes. Chemical bonds systematically break apart and reform into entirely new molecular configurations. Here's the profoundly unsettling aspect. We genuinely don't know how thick this transformed crust extends into the interior. We cannot determine whether solar heating will erode it away to reveal pristine material underneath, or whether the entire object has been transformed completely. Maggiolo stated that scientists absolutely need to take these aging processes into account when analyzing 3I Atlas. You cannot simply assume you're observing a fresh, unmodified sample from another star system. However, he also expressed something genuinely hopeful. He stated that 3I Atlas remains profoundly interesting despite this complication, because if we can develop comprehensive understanding of how the radiation crust formed, and if we can compare observations obtained before Perihelion with observations collected afterward when solar erosion might have exposed deeper layers, we might still glimpse the original primordial composition hidden beneath. That's precisely what the scientific community eagerly awaits. The comet has passed perihelion, surviving its closest solar encounter. It's now moving steadily away from the sun. Throughout November and December 2025, right now during this critical window, it will become visible again from Earth-based observatories as it continues its departure trajectory. This represents our observational window, our singular opportunity. This is when we might definitively determine if intense solar heating successfully stripped away sufficient material from that radiation-processed crust to reveal whatever lies underneath. The trajectory of 3I Atlas proves genuinely unusual when subjected to careful orbital analysis. It's traveling at velocities exceeding 130,000 miles per hour relative to our solar system, moving along what observers have characterized as an unusually flat and remarkably straight path. This isn't the chaotic curved trajectory you'd expect from an object that formed within our solar system and has been gravitationally influenced by planetary bodies for billions of years. This represents a trajectory that practically screams, "I originated from somewhere else entirely." Certain age estimates based on radiation damage analysis suggest 3I Atlas could measure approximately 7 to 12 billion years old. That would render it approximately 3 billion years more ancient than our entire solar system. Pause and contemplate that. This object existed before our sun ignited, before Earth coalesced, before any familiar planets came into existence. It has been traveling through the galaxy since an epoch when the Milky Way exhibited completely different structure. What has this ancient wanderer witnessed? What environments has it passed through? What stellar systems did it drift past in the darkness? We know it originated from somewhere in the galactic frontier, possibly from the outer regions of the early Milky Way. However, we don't know where it originally formed, which star it once orbited, or what happened to that parent star. What we do know with certainty is that right now, 3I Atlas is steadily moving away from our sun, heading back toward the interstellar darkness from which it emerged, and we possess only a limited observational window to gather as much data as possible before it fades from view forever. Once it departs beyond detection limits, we'll never see this particular object again. This represents a singular one-time opportunity. That reality brings us back to Avi Loeb's formal request to NASA for complete data transparency. Professor Loeb has been consistently vocal about the absolute need for openness when confronting interstellar objects. He served as one of the leading voices calling for serious investigation of Oumuamua, the first confirmed interstellar visitor in 2017. Loeb suggested then, and maintains now, that we should never dismiss unusual possibilities when confronted with genuinely unusual data that doesn't fit comfortable explanations. He argued that Oumuamua's elongated shape, its unexpected acceleration as it departed the solar system, and its conspicuous lack of visible cometary activity represented genuine anomalies deserving rigorous investigation rather than rushed conventional explanations designed to avoid controversy. Now, with 3I Atlas presenting its own catalog of anomalies, Loeb is calling on NASA to release all accumulated scientific data to the broader international research community. His argument proves straightforward. This represents an object of extraordinary scientific importance, regardless of what it ultimately proves to be. It's only the third confirmed interstellar visitor humanity has ever detected. The data collected by NASA's extensive instrument suite represents humanity's best and possibly only chance to comprehensively understand what interstellar objects are genuinely like. That precious data shouldn't remain siloed within institutional boundaries. It should be made available for independent analysis by qualified researchers worldwide. However, there exists an unspoken question underlying Loeb's request that many researchers are thinking about privately. What exactly is contained within that data that hasn't been discussed publicly? What has NASA observed that doesn't fit easily into press releases? Are there measurements, spectral features, or behavioral patterns that resist comfortable conventional interpretation? The scientific community finds itself divided on how to properly interpret 3I Atlas. Certain researchers feel comfortable with explanations suggesting it's simply a comet, exhibiting unusual but ultimately natural composition, modified by cosmic radiation, behaving in ways we haven't previously seen because we've never studied an interstellar comet this closely with such sophisticated instruments. However, other researchers remain less certain about comfortable conventional explanations. They systematically point toward the accumulated anomalies, the explosive brightening that doesn't match any models, the missing dust tail that should be present, the perfectly flat trajectory exhibiting minimal gravitational perturbations. They ask quietly in research papers, what alternative explanations could potentially account for these collective observations? Nobody in positions of professional responsibility is stating it outright in official publications. Nobody wants to become the scientist who jumps prematurely to extraordinary conclusions without overwhelming evidence. However, the questions persist. What if 3I Atlas isn't entirely natural in origin? What if something about its composition, its structural architecture, or its behavioral patterns suggests it represents more than merely a ball of ice and rock that's been drifting through space for billions of years? Here's what makes that question so profoundly uncomfortable. We possess no established framework for properly answering it. Our entire scientific understanding regarding comets, asteroids, and interstellar objects rests fundamentally on natural formation processes. We observe spectra, detect carbon dioxide and water, and immediately conclude comet. We measure an elongated shape and immediately think fragment from a planetary collision. However, what if the signatures we're trained to interpret possess multiple possible explanations? What if certain things we're observing could remain consistent with both natural and artificial origins depending on context? How would we even reliably know the difference? This discussion isn't about prematurely declaring 3I Atlas as anything other than what it superficially appears to be. This is about acknowledging with intellectual honesty that our statistical sample size for interstellar objects measures exactly 3: Oumuamua, Borisov, and now 3I Atlas. 3 objects total out of potentially billions drifting through our galaxy. We're attempting to draw sweeping conclusions about an entire phenomenological class based on 3 examples. That doesn't constitute robust science. That represents preliminary observation at best. Each of those 3 confirmed interstellar visitors has presented humanity with genuine surprises that challenged predictions. Oumuamua accelerated in ways that couldn't be satisfactorily explained by conventional outgassing alone. Borisov appeared relatively normal compositionally, but arrived from a different stellar environment carrying different chemical signatures. Now 3I Atlas is brightening explosively, losing water at unprecedented rates, and systematically challenging our models. Perhaps all 3 represent purely natural objects exhibiting unusual properties that simply reflect the diversity of formation environments across the galaxy. Perhaps the universe proves far more diverse than we've given it credit for based on our limited local sample. That represents the simplest explanation requiring the fewest assumptions, and it's quite probably correct. However, the sheer explosiveness of 3I Atlas's brightening behavior, the precise timing coinciding exactly with perihelion, the way it manifested right at closest solar approach, these factors keep nagging persistently at certain researchers who cannot quite dismiss the coincidences. Because there exists a meaningful difference between unusual, but ultimately explainable within existing frameworks, and unusual in ways that suggest something we haven't seriously considered. Let's discuss what happens next, because the story of 3I Atlas remains far from concluded. As the comet moves progressively away from solar heating, it will remain observable throughout November and December. Astronomers worldwide are pointing their telescopes toward it continuously, collecting spectroscopic data, meticulously measuring brightness variations, carefully tracking any changes in activity level. The question everyone wants answered proves remarkably simple to state. Will the dramatic activity decrease now that it's moving away from intense solar heating? Or will something else manifest? Zhang and Batams noted that the post-perihelion evolutionary trajectory could prove just as unusual, perhaps even more anomalous, than the pre-perihelion outburst. One straightforward possibility suggests the comet will simply fade as thermal models predict. Solar heating decreases with distance, sublimation rates slow proportionally, brightness drops accordingly, and 3I Atlas becomes a progressively dimmer speck, gradually disappearing into observational noise. That would represent the normal expected scenario. Another distinct possibility suggests the activity continues, or potentially even increases beyond current levels. If something exists inside the nucleus, some volatile material reservoir that's now been exposed by erosion of protective outer layers, it could continue outgassing vigorously even as the comet moves away from the sun. That observational outcome would definitively tell us the internal composition differs radically from the surface. However, there exists a third possibility that absolutely nobody wants to articulate publicly. What if the behavioral patterns change in ways that cannot be explained by solar heating dynamics at all? What if there emerges a discernible pattern suggesting internal processes rather than external heating? What would such an observation actually mean for our theoretical frameworks? The two Mars rovers, Curiosity and Perseverance, actually possessed a unique observational opportunity to study 3I Atlas from their distinctive vantage point on Mars. Their observations provided an entirely different geometric perspective that could potentially reveal structural details remaining invisible from Earth's position. The complete data from those Martian observations hasn't been fully released to the public yet. What precisely did they observe? The comet approached close enough to the sun that the solar wind would have interacted directly with its coma, the cloud of gas and dust surrounding the central nucleus. That direct interaction inevitably creates observable effects: plasma instabilities, magnetic field distortions, particle acceleration processes. These effects can reveal information about composition and internal structure in ways that simple spectroscopy alone cannot access. NASA's STEREO mission captured detailed imagery showing 3I Atlas actively interacting with the solar wind during perihelion passage. Those images revealed complex structures within the coma, pronounced asymmetries in the gas distribution patterns. However, properly interpreting those patterns requires understanding not merely cometary physics in isolation, but plasma physics, magnetohydrodynamics, and the extraordinarily chaotic environment characterizing near-solar space. This represents exactly why Loeb's persistent call for data transparency matters so profoundly. The more eyes examining this data, the more diverse perspectives brought to bear on interpretation, the better chance humanity has of understanding what's genuinely happening. Perhaps one research group will notice something subtle that another group overlooked. Maybe an independent analysis will reveal an underlying pattern that fundamentally changes the entire interpretation. 3I Atlas proves unusual enough across multiple parameters that it absolutely deserves that maximum level of scrutiny from the global scientific community. Some observers have noted that the precise timing of 3I Atlas's dramatic outburst, coinciding almost exactly with perihelion, seems suspiciously precise. Natural physical processes typically prove messy and chaotic, characterized by gradual changes rather than sudden transitions. So why did the brightness surge happen exactly when it did with such remarkable timing? The conventional scientific explanation invokes threshold effects operating in thermodynamic systems. As the comet progressively heated approaching the sun, it reached a critical temperature threshold where the sublimation rate suddenly increased dramatically. The protective carbon dioxide layer depleted at a specific distance, and once it disappeared, the water ice underneath found itself exposed all at once, leading to the rapid brightening. That explanation proves plausible and consistent with known physics. However, there exists an alternative interpretation that certain researchers find genuinely compelling despite its controversial implications. What if this object was deliberately designed to activate at a specific distance from stellar bodies? What if the outburst wasn't caused purely by passive thermal heating, but by some internal mechanism triggered by proximity to our sun? Before you dismiss that speculation as science fiction, consider this fact. Humanity has already sent numerous probes throughout our solar system that activate at specific times or under carefully defined conditions. We've built sophisticated satellites that wake from hibernation when onboard sensors detect solar radiation exceeding specific threshold levels. The fundamental concept of a threshold-triggered system isn't exotic speculation. It represents basic systems engineering that we routinely implement. The relevant relevant question isn't whether such technological approaches are theoretically possible. They manifestly are. The critical question demanding evidence-based answers is whether there exists any observational data suggesting 3I Atlas represents anything other than a natural object. The honest answer that maintains scientific integrity is that we don't yet possess sufficient data to conclusively rule anything out. What makes 3I Atlas particularly intriguing is its substantial mass. Early estimates suggest this object possesses a mass of approximately 33 billion metric tons. That represents an enormous mass for a cometary body. Most comets we routinely observe measure far smaller. The nucleus of Halley's comet is estimated at around 22 billion tons. So, 3I Atlas significantly exceeds the mass of one of the most famous comets in human history. Now, mass alone doesn't automatically signify anything unusual. However, when combined systematically with the other accumulated anomalies, the exceptionally high velocity, the explosive outgassing behavior, the unusual trajectory exhibiting minimal perturbations, it adds yet another data point to a progressively growing list of characteristics that make this object stand out prominently. Then, there's the velocity component. Moving at 130,000 miles per hour represents a very specific energy state with profound implications. This object is moving sufficiently fast to escape not merely our solar system's gravitational influence, but to traverse the vast distances separating stellar systems across billions of years. It's been in continuous transit for such an extended duration that the original star it formed around might not even exist anymore in any recognizable form. That parent star could have already evolved completely off the main sequence, swelled into a massive red giant, subsequently shed its outer atmospheric layers, and collapsed into a dense white dwarf. All of these stellar life cycle stages could have occurred while 3I Atlas was simply wandering through the galactic darkness. Think about that incomprehensible journey spanning 7 to 12 billion years. If these calculations are correct, this mysterious object has been traveling continuously since before complex multicellular life existed anywhere on Earth. It passed through regions of space subjected to conditions we can only theorize about. It survived countless encounters with other stellar systems, experiencing gravitational perturbations from massive objects, exposure to radiation from sources including supernovae, passages through dense molecular clouds. Yet it emerged from all of that extended cosmic gauntlet intact, still maintaining structural coherence, still recognizable as a discrete, unified object, rather than a dispersed cloud of debris. That survival alone represents something genuinely remarkable. The survival rate for objects traveling through interstellar space across billions of years should be relatively low. Collisions, gravitational disruptions, progressive radiation damage causing structural failure, all represent existential threats. Yet 3I Atlas is here, apparently intact, apparently functioning in ways that suggest it's held together remarkably well despite its ancient origins. The extensively irradiated crust that Webb detected might actually constitute a significant part of the survival explanation. That 50 to 65 foot thick layer could be functioning as protective armor, actively shielding the interior regions, maintaining structural integrity. It's essentially a hardened shell forged gradually by billions of years of cosmic ray impacts, rendered harder and more resistant than the pristine ice underneath. In a very real sense, the extended journey itself made 3I Atlas progressively more durable. However, here's where the situation becomes interesting from an engineering perspective. If you were designing a probe intended to travel between stellar systems to survive the extraordinarily harsh environment of interstellar space for billions of years, what design principles would you implement? You'd need comprehensive protection from intense radiation. You'd require structural integrity capable of withstanding micrometeorite impacts. You'd need a design accommodating extreme temperature variations. You'd probably want the system to be primarily passive, not requiring active systems consuming power for the vast majority of the journey, only activating when encountering specific conditions like proximity to stellar systems. An irradiated protective crust would elegantly serve many of those critical functions simultaneously. Now, I'm explicitly not claiming that's what 3I Atlas actually represents. I'm simply pointing out that if you systematically examine the characteristics we've observed, the extreme age, the substantial mass, the protective radiation-processed crust, the threshold-triggered activity coinciding with solar approach, you're observing a collection of properties that would also remain entirely consistent with a designed object specifically engineered to travel between stellar systems. That observation doesn't prove anything definitively. It simply means we absolutely should be thorough in our analysis. This represents precisely why the scientific method exists. You don't start with predetermined conclusions. You systematically gather all available data. You formulate multiple competing hypotheses. You actively look for ways to distinguish between competing explanations through targeted observations. And right now, we desperately need more comprehensive data to test these various hypotheses. The observations streaming in over the next several weeks will prove absolutely critical. If 3I Atlas fades predictably according to refined thermal models, if its behavioral patterns match updated models of irradiated comets, then we'll have developed a robust natural explanation successfully accounting for everything we've observed. However, if the behavioral patterns continue deviating from predictions in systematic ways, if there emerge patterns that don't correlate properly with solar distance, if the spectroscopic data reveals compositional features that fundamentally challenge our understanding of natural comet formation processes, then we'll need to substantially expand our hypothesis space. We'll need to seriously consider possibilities that currently seem unlikely or uncomfortable to discuss publicly. That prospect proves uncomfortable for many scientists because once you start entertaining hypotheses falling outside conventional frameworks, you open yourself professionally to criticism, to accusations of engaging in speculation, to being labeled as fringe or sensationalist. However, that understandable discomfort absolutely shouldn't prevent us from following observational data wherever it leads. Loeb has been consistently vocal about this fundamental issue. He's argued repeatedly that the professional stigma surrounding discussions of non-natural origins for unusual objects is itself profoundly unscientific. Science is supposed to remain agnostic about outcomes, evaluating hypotheses purely on evidential merit. You propose testable hypotheses. You systematically test them against accumulating evidence and follow the results wherever they lead. If an artificial origin hypothesis can be rigorously tested and potentially falsified through observations, then it represents a valid scientific hypothesis regardless of how uncomfortable it makes people feel. The genuine challenge lies in determining what specific observations would actually distinguish reliably between natural and artificial origins. What would we reasonably expect to observe differently? For a purely natural comet, we'd confidently expect activity to correlate directly with solar heating intensity. We'd expect the composition to fall within known ranges for ices and rocky materials formed in protoplanetary disks. We'd expect structural variations to appear random. We'd expect the trajectory to exhibit small perturbations from outgassing. For something deliberately designed, we might reasonably expect precise threshold behaviors, activity that switches on or off at carefully defined conditions. We might expect unusual symmetries in the internal structure. We might expect trajectory corrections that cannot be explained adequately by passive outgassing alone. We might expect radio emissions at specific frequencies suggesting modulation. Have we systematically looked for those distinguishing characteristics? Have we conducted the comprehensive tests that would allow us to distinguish between these competing possibilities? That's precisely what Loeb is requesting NASA to enable through complete data transparency. Because here's the fundamental reality we must acknowledge. We are genuinely living in a moment of cosmic significance. For the first time in human history, we possess the sophisticated technology necessary to detect, systematically track, and comprehensively analyze objects originating from other stellar systems. We can point our most advanced telescopes at these mysterious visitors and gather detailed data that would have been completely impossible even 20 years ago. The James Webb Space Telescope is providing us with insights into composition and structure at unprecedented resolution levels. Our extensive network of space-based observatories provides continuous monitoring capabilities that ground-based telescopes alone could never achieve. This represents the golden age of interstellar object research, but it's also a frustratingly brief observational window. These objects pass through quickly. 3I Atlas will be gone completely within several months, and we may not encounter another confirmed interstellar visitor for years or potentially decades. Each confirmed visitor is precious beyond measure. Each one represents an opportunity we cannot afford to waste through incomplete analysis. That's why the explosive brightening matters so profoundly. It's why the conspicuously missing dust tail matters. It's why the radiation-processed crust matters. It's why every single anomaly, every unexpected behavior, every deviation from our carefully constructed models deserves serious attention. Because we're not merely studying another comet adding incrementally to our knowledge. We're actively gathering data that could fundamentally reshape our understanding of what exists throughout interstellar space. Think carefully about the implications. If interstellar space is genuinely filled with objects resembling 3I Atlas, billions upon billions of them, drifting continuously between the stars, carrying within their structures the chemical signatures of distant stellar formation environments, possibly even carrying the fundamental building blocks enabling planets yet to form. The galaxy becomes a vast interconnected ocean of potential. However, think equally carefully about the implications if even a small statistical fraction of those countless wandering objects represents something else entirely. If among the countless natural comets and asteroids, there also exist artifacts, deliberately constructed probes, engineered constructs sent out by civilizations that existed millions or billions of years ago. What would that discovery mean for our fundamental understanding of intelligence distribution throughout the universe? We've searched diligently for radio signals emanating from the stars. We've looked for laser pulses, for engineered megastructures, for any sign that we're not alone. But perhaps we've been looking in entirely the wrong places. Maybe the evidence isn't out there among the distant stars. Maybe it's here, passing directly through our own solar system, effectively disguised as natural objects, because that's exactly what they're constructed from. Interstellar probes designed by advanced civilizations wouldn't resemble spaceships from science fiction. They'd look like rocks, like ice, like comets, indistinguishable from natural objects without detailed analysis. They'd blend seamlessly into the background population. The only way we'd reliably know the difference is through careful, extraordinarily detailed analysis of their behavior and internal composition. The next several weeks will reveal a tremendous amount of information. As 3i Atlas moves progressively away from the sun, as we continue systematically monitoring its brightness, its emission spectrum, its trajectory, we'll gather more crucial pieces of this complex puzzle. Maybe those pieces will fit together elegantly into a clear picture of an unusual but entirely natural comet. Maybe they'll reveal patterns that challenge our current understanding and force us to expand our theoretical framework significantly. Or maybe, just maybe, they'll show us something we genuinely weren't expecting, something that makes us fundamentally question our assumptions about what's possible, about what exists out there in the darkness between stars, about whether we're truly as alone in the universe as we've always believed based on limited evidence. One thing remains absolutely certain: we're watching intently. Right now, telescopes distributed around the world and positioned in space are pointed directly at 3i Atlas. Scientists are meticulously analyzing spectra, calculating trajectory refinements, modeling internal structures. Amateur astronomers are enthusiastically sharing observations, comparing notes across continents, contributing meaningfully to a global coordinated effort to understand this mysterious visitor. The data is accumulating steadily. The picture is becoming progressively clearer with each passing observation. Whatever we ultimately discover, whatever the final answer turns out to be after comprehensive analysis, it will inevitably change something fundamental about how we perceive the universe and our place within it. Because every interstellar object teaches us something genuinely new about conditions beyond our solar neighborhood. Every visitor from the darkness brings with it encoded information we couldn't obtain through any other observational method. Every anomaly represents an opportunity to refine our theories, to test our foundational assumptions, to push the boundaries of what we know. 3i Atlas originated from somewhere in the distant galactic environment. It traveled continuously for billions of years to reach our solar system. It survived conditions we can barely imagine or model accurately. And now, for a brief, fleeting moment in cosmic time, it's here, in our neighborhood. Close enough for us to study using our most sophisticated instruments. Close enough for us to learn from if we ask the right questions. It's performing in ways we didn't predict. It's behaving in ways that actively challenge our carefully constructed models. It's revealing properties that force us to think harder and more creatively about what interstellar objects genuinely represent. The fundamental question isn't whether 3i Atlas exhibits strange characteristics. It clearly does. The real question demanding answers is what that accumulated strangeness actually means for our understanding. Is it the strangeness of a natural universe proving far more diverse and complex than we've given it credit for? Or is it the strangeness of something else entirely? Something that makes us reconsider fundamental assumptions about our place in the galaxy and whether we're alone. Time will provide answers. The accumulating data will provide answers. That's why we need comprehensive access to all of it. That's why transparency matters so profoundly. Because in the end, this isn't merely about one mysterious object passing through our solar system. It's about how we systematically approach the unknown as a scientific civilization. It's about whether we're genuinely brave enough to follow observational evidence wherever it leads, even if it takes us to conceptually uncomfortable places. It's about whether we're willing to ask difficult questions and accept uncertain answers. 3i Atlas is still out there at this moment, moving steadily away from us at over 100,000 miles per hour, carrying its accumulated secrets back into the darkness from which it emerged. But for now, for these precious remaining weeks while it remains visible to our instruments, we have a genuine chance to learn, to observe carefully, to question assumptions, to wonder about possibilities, and maybe, just maybe, to discover something that changes everything we thought we understood. The interstellar visitor has arrived, has performed its unexpected and dramatic display, and is now steadily departing back into the void. What it leaves behind is questions. Profoundly important questions. Questions that deserve comprehensive answers based on complete data analysis. The universe is speaking to us through these mysterious objects. Are we listening carefully enough to hear what it's genuinely saying? Are we asking the right questions? Are we being thorough enough? Only time and continued observation will provide those answers, but we must ensure we're doing everything possible to gather the data necessary for understanding. Because opportunities like this arrive rarely, and when they do, we cannot afford to waste them through incomplete analysis or premature conclusions. 3i Atlas represents a gift from the cosmos, a chance to learn something new, something potentially profound. We must seize this opportunity with everything we have.